Hello! We are nearly done. 2 more lessons to go. This is the next to last lesson. And it relates to what we did in our previous lesson, where we did cross sections. Well, this time, we're revolving or rotating a shape. They actually call it a volume of revolution. We're taking a graph, like such, and we're revolving it around a line. In this case, we're revolving around the x-axis. And when we do that, we create a shape that looks like this. Notice all the cross sections are circles. So in essence, we're going to try to find areas of all these cylinders and add them up. But eventually, we want the cylinders to be so tiny, they're almost like flat circles, and we want an infinite number of them, because that's what we do in calculus. So here's what we do. Our formula is exactly the same as the cross sections. Remember in the last lesson, we found cross sections. They could have been squares, rectangles, semicircles, equilateral triangles. Now, if you revolve it around an axis or rotate it, that cross section is always going to be a circle. So specifically, for this called the disk method, and it's called the disk method because if you were to take a piece of this out and look at it dead on, it would look like a solid disk. For the disk method, we're using the area of a circle, which is pi r squared. And we're taking basically the antiderivative of it. So pi is a constant because it stays outside. We're going from A to B, so in this case it's wherever it starts to wherever it ends, of the radius squared. And the radius is always going to be an equation that relates to the graph. Okay? I always said it's going to be an equation. That's always true, but sometimes equations can be whole numbers, which you'll see in this next example. All right, let me show you how this gets generated. Because remember, we're looking at the graphs of y equals 3 and x equals 5. And the y-axis and the x-axis. So we're looking for this shape right here, this shaded shape right here. So take a look at this. We're going to rotate around the x-axis, which is the line y equals 0. The function we chose was 3. Now in this particular program, we have to tell the limits of integration. So we're going to go from 0 to 5. So you're going to notice that it only graphed the line from 0 to 5. Because this is the region under the curve that we're going to rotate and make a volume. Now if we're going to rotate this around the x-axis, it's going to be spinning around the x-axis. Sometimes it's easier to see with a three-dimensional perspective. So what will that look like? Here we go. So you kind of see it spinning around the x-axis, a three-dimensional shape. And this is a cylinder. Alright, you see how this got created. Our goal for this method is always to figure out what the radius is. Now the radius goes from our center of rotation out to our edge. On the three-dimensional shape here, what that would look like, whoa, that's not good. It's close, but not perfect. Let's try it from the top. That's okay. So we have that circle that's in there. Well, the circle's radius is from the x-axis out to the edge. So this shape right here, this little distance, is our radius. Now we're rotating about the x-axis, which means the x-axis is our center of rotation. So we're going from that out to the edge. So it's perpendicular to the x-axis. So we do things in terms of x. And in this case, we're going from 0 to 5. Our equation is really just this line, and that distance from there to there is just 3. Our equation was y equals 3. That is our formula. So if we go and figure that out with the calculator, we get 141.372. Now I'll tell you something interesting. Well, maybe interesting, I don't know. But a way to check this answer, you guys know this is just a regular old cylinder, isn't it? A cylinder that has a radius of 3 and a height of 5. And you know the volume formula geometrically for the volume of the cylinder is pi r squared h. So you kind of see how that all fits over here? The pi r squared is here, here, and here. The h is from 0 to 5. Technically, it's our height. Now, if you plug in 3 and 5 into this equation, you're going to get 141.372. Okay? So, our goal is always to find the radius. Here we have the equation y equals negative x squared plus x, and the x-axis. So it's a bounded shape. Many times you'll be given what the boundaries are. Sometimes you've got to figure out where they intersect. On the problems I gave you to try, you have to graph them. And I suggest graphing them on a calculator on Desmos and taking a look at them and determining where the endpoints are. But in these examples, I've given you all the endpoints. But let's see how this shape gets formed. All right, the next function I want to look at is negative x squared minus x, or plus x, I'm sorry. And we're going to go from 0 to 1. What would this graph look like when it's revolved? Gives me the impression of a football. It's not quite as much more pointy than a football, but that would be your solid shape that you created. All right, you saw how that is created. And if we spin this, there's our little cross section, our disk, and our radius is from the center of rotation, which is the x-axis, out to the edge, which is what this box represents. So unlike the last problem, the radius is not a constant, it's not a number. The radius is always changing, but the radius is dependent upon the graph. Remember, this is a y value. Straight up and down is a y value. So this radius is a y value. Well, what does y equal? Negative x squared plus x. So this distance is actually negative x squared plus x, and it depends on where you are along the axis. So, since it's perpendicular to the x-axis, we're doing it in terms of x. The height, technically, or the distance from A to B is 0 to 1. The expression for the radius is this. There's your setup. Again, I know you guys could square that out and do it by hand, but there's no point. I don't really mind you using the calculator because I know you know how to take integrals. This is a very, very tiny answer, but it kind of makes sense. This only goes from 0 to 1, and the height of this reaches a quarter. So it's a small object. So that seems pretty reasonable. All right, hopefully that makes sense, because now we're going to, of course, throw something different out there. Now I've got the equation of y equals negative x plus 4 and the first quadrant. So I'm looking at this shape right here. I know it's 0, 4 is up here, and 4, 0 is here, and 0, 0. So the shape is all in there. Let me show you how that gets generated to become this, because we are now rotating around the y-axis. All right, that's our difference. So take a look. This piece of this graph, we're going to rotate around the y-axis. So you may have an idea of what it looks like, but here we go. That will be the graph of a cone. So that's a cone. When you look on it dead on, it looks like a triangle. But remember, it's a cone. So the cone has cross sections of circles because we are revolving it. That is the idea. Anytime you revolve it, you've got a circle. So we're going to use pi r squared. And the radius will be the distance from the y-axis, which is the center of rotation, to the edge. All right, you saw how that was made. So, if we're going around the y-axis, this is our center of rotation. And that is our radius. Our radius is now going to be this way. This is an x distance. Horizontal distances are x distances. So since it's a horizontal distance, or some say because it's perpendicular to the y-axis, we're going to have to use this in terms of y. So instead of x, now we're going to put the expression in terms of y. And the reason is this distance comes from the y-axis. It's an x distance. Now this equation is solved for y. So that's not going to help me. I need to know what this is solved for x. So I'm going to solve it for x. And then subtract y from both sides. Okay. So these two equations, actually all three of these are exact same equation, just rewritten. But now this distance, which is an x distance, is given by the expression 4 minus y. So it's actually 4 minus y squared dy. And where do the y's go to and from? The y's start at 0 and go up to 4. Alright, we put that in the calculator and we come up with the answer of 67.021. That's how we revolve and get an answer. Alright, so we're going to change it up again. Oh, I've got a hole. Now what do? My two equations that I'm going to find are the square root of 25 minus x squared, which is this one, and g equals 3. And they happen to intersect at negative 4 and 4. So here's my shape. And I'm going to spin this shape around the x-axis. So let's see how that gets generated. We are going to use the graph, the square root of 25 minus x squared. So the way I have to type it, I'm going to do it like this and raise the whole thing to the half power. So that's the square root of 25 minus x squared. And I have a second function, g. So I want to go from negative 4 to 4. So we're going to rotate this around the x-axis. So here's what it would look like. Notice we have an outer shape and an inner shape. The blue region represents the outer shape. The green region represents the inner shape. So if you think about it, what we've got is we've got part of a sphere. It's like a part of a sphere with little ends cut off, and a cylinder on the inside. And this graph has to be very, very accurate because there will be a giant hole through the middle of this shape. You notice there was a gap in the middle. So they call this the washer method. They call it the washer method because I have two radii. I've got the outer edge and then I've got this inner circle. And they call it the washer method because if I looked at it dead on, I see this, which is a washer. You know, like the old washer that you put onto a bolt when you screw it in. So they call it the washer method. And all that it means is it has a gap. If it has a gap, it means it has two radii. So a lot of times this is written as its own separate equation because you have a gap. So you'll see this written in books a lot of times. This way. You're going to have one radius, which is your outer radius. You're going to subtract the inner radius. Just like in geometry, if you try to find an equation, let's say it's just this washer in general. If you want to try to find the area of this washer, you had to take the area of the whole circle and subtract the area of the inside circle. That's how you found it. And that's what this is. So now the question is, can you find expressions for both of these radii? Well, we're spinning it around the x-axis, so if I go straight up to the top, I hit that. Well, what is that distance from there to there? Well, that's your graph. That's your equation. So that first radius is the square root of 25 minus x squared squared. Okay? Your second radius, our gap, the radius of our hole in the middle, is from here to here. This function is 3. So this distance is 3. And since these distances are vertical, they're wide distances, which means we put them in terms of x. So that's why I put these in terms of x. And x goes from negative 4 to 4. And we just plug that in the calculator, and we get the answer. That's approximately 348.507. Okay? All right, let's add more to it. Now we're revolving it not around one of the axes, but we're actually revolving it around the line y equals -1. So we're taking the graph of y equals x plus 2, the graph of y equals 2, and the graph of x equals 5, which creates this region here. We're going to rotate it around the line y equals -1. All right, let's see how this gets generated. All right, here's our function of x plus 2, our other function of 2. We're going to go from 0 to 5. There's the region. We're going to be rotating it around the line y equals -1. So take a look. Notice from -1 that makes this a wider swing because, oh, it's got more distance to travel. So there we go. Got a nice little hole in that graph. Reminds me a little bit of my least favorite hole on a miniature golf course where you have to hit it up the hill into the cup. Anyway, there it is. Okay, there's a gap. So it's a washer method. So if it's a washer method, we have 2 radii. Now our cross sections are still coming from the line y equals -1. It's still perpendicular to the x-axis. So we need these in terms of x. So it's going to be a radius 1 in terms of x squared minus our second radius in terms of x squared. Okay. So now here it is. Going from x, x now we know goes from 0 to 5. What's the distance from here to here? Okay. Well, the distance from the axis to the edge is just the function, and it's just the function x plus 2. But how much more am I adding here? So from here to here, it's x plus 2 plus 1 more. Okay, so make sure you guys can see that okay. The distance from the axis to the outer edge is the function x plus 2, and that little gap is 1 more. So this distance is x plus 2 plus 1 more, or x plus 3. And the gap is this one. How long is that gap? Well, it's 2 and 1 more, so it's 3. And that's what we got. Throw that in the calculator. See what we get. This nice answer of 366.519. Alright. Hopefully you're hanging in there. I've got one last example that's going to kind of put it all together, I hope. Okay. So this last example, we're going to do the same shape. And we're going to set up integrals. We're not going to solve them. We're just going to set them up. And I want to show you how you don't have to necessarily see the three-dimensional shape in order to get it right. All right, so this example is going to include a lot of questions with the same figure. So our figure is y equals the square root of x and y equals 3. And they intersect here at 9, 3. So they create this shape that's in green. So this is the shape that we'll be rotating. Now in our first example, we're going to rotate it around the y-axis. Now just a little note, we're only going to set up these integrals. We're actually not going to calculate them. We're just going to set them up. All right. So since we're revolving around the y-axis, that is our radius. So what is that expression? Now because this is perpendicular to the y-axis, we have to put these in terms of y. So our volume is going to be pi times our limits of the radius with respect to y squared. The y values go from 0 to 3. That's not a very good 0, is it? Let's try that again. Good, 0 to 3. And And what's this expression? Well, we know that the y equals the square root of x, which means that y squared equals x. So remember, it's a horizontal distance, and horizontal distances are your x distances, and x equals y squared. All right. So remember, wherever you're perpendicular to, that's the variable you will use. You're perpendicular to the y-axis, you use y's. And this will give us our area. Okay, same shape, but now we're going around the x-axis, which means I'm spinning it around here. Which means, oh look, I've got a gap. Here's my outer one right there. And my inner is here. So see how I've got this nice big gap when I spin this around. And you just tell that there's nothing there. So that's a washer method. Now if it's a washer method, that means I have two radii. And because these are perpendicular to the x-axis, I'm doing it in terms of x. So the first radius minus the second radius. Okay. All right. X is going from 0 all the way to 9. And my first radius is this. Well, that's a pretty easy one. That distance from there to there is just that equation of 3. My inner distance from here to here is this equation. So this distance is the square root of x. And that is my integral. That's my square root of x, that's my 3. We'll keep that in mind now, because now I'm going to go and spin it around the line. Not that, I'm going to spin this around the line y equals 3. So I'm going to spin it up this way. My radius is going to be from where I'm starting to the outer edge of my shape. Remember, my shape ends here. I'm spinning this around. Is there a gap in this shape? And there is not a gap, because I'm taking this shape and spinning it around. There's no gap from where I'm revolving it around to where I hit the graph. So it's a disk method. These are perpendicular to the x-axis, so I'm using x's. Oops, a few too many parentheses. So my trick is, well, I know it's x's, so I know this is going from 0 to 9. What is this distance? So this distance, we have to use both graphs. Because remember, the distance from here all the way up to here is 3. The distance from here all the way up to here is square root of x. So do you see why this distance in the dotted blue line is 3 minus the square root of x? Right, because that's 3, and then I took away the square root of x to get that distance. Okay. Those get a little tricky. Okay, but keep it up. Keep persevering. You'll get it. All right, the line. Oops. All right, now we're rotating this around the line. X equals 9, so this one out here. Oh boy. So here's our rotation. So let me draw an arrow. I got all this gap in here. I'm going to hit that. That's going to be my outer radius when I spin this around. And this is going to be my inner. I'm going to have a gap in this case. Definitely have a gap. So if I have a gap, it's a washer method. Now these radii are perpendicular to the y-axis. So we're going to be using these things in terms of y. So let's figure out our two radii. We know that the y's go from 0 to 3. Radius 1. Well, that should be a nice easy one to see. The distance from there all the way to there is just 9. So that's 9. That will be 9 all the way. Now this distance here, that's the one's a little trickier. Because remember, the whole distance all the way out to the edge is 9. But remember, this is a graph of y equals the square root of x. Now we're putting it in terms of y. So remember, x equals y squared. So this distance here to here, that's y squared. Of course, y squared varies. If we're going up here, that's y squared. So it all depends on how you think about it, like where you go to and from. But it's always the same. The distance from here to the edge, is always 9. And I'm taking out these pieces. And these pieces are y squared. I should put a y there. Sorry about that. All right. I know it gets complicated, so when we come online Tuesday, you have questions on that, I can help you with those. All right, last one. Next to last one. All right, the line y equals 4. Well, I've already drawn it for you. There's the line y equals 4. That's what we're spinning it around. Not that. We're spinning around this one. So I'm going to have a gap, aren't I? From here to here is a gap. But since my line y equals 4, this is my outer edge, this is my inner edge, or my inner and outer radius. And I have a washer, so I have a gap. So if I have a gap, I gotta do 2 radii. These cross sections are perpendicular to the x-axis, which means now I am using these in terms of x. All right, what are my 2 radii? Well, I know x goes from 0 to 9. Now the inner one's pretty easy. The inner one's going to be 3. Oh, not going to be 3. Sorry, what's the distance from here to here? That's 1. Distance from here to here is 1. The inner radius is always going to be 1. But what about this distance? Okay. Now to get this distance, remember, we've got to do the whole distance. What's the entire distance from the edge of that graph to the x-axis? Well, the whole distance is 4. Okay. But I'm taking out this much. So I took this part out. And what is that distance? Well, that distance is x squared. I'm sorry, that distance is the square root of x. So this radius right here is the whole thing 4 minus the square root of x. My inner radius is just this distance from here to here, which is 1. Now, technically, if you want to think about it, technically, this distance here is the whole thing of 4 minus 3, but it's still 1. All right? Now the last question. The line y equals 10. We're spinning around the line y equals 10. I have 2 radii. from here all the way to here, here to here, I definitely have a gap. So if a gap, it's a washer method. If it's a washer method, we have 2 radii. And because these are perpendicular to the y-axis, we're going to be using them in terms of y. Now, interestingly enough, this is going to be very, very similar to this one. Just really changing one number. And you'll see why in a second. So what is the distance from here all the way to the edge, or outer radius? Oh, before I do that, it goes from 0 to 9. Yeah, let's make it nicer. Let's keep it consistent here. Oh, that's 10. The distance from here to here is 10. Minus, what's the distance from here to here? Remember, the whole distance from there to there is 10. And I'm taking away this part. That part, remember, we're using it in terms of y. That part is really y squared. So I want you to see something you didn't notice it before. If I go back to this one, what changed? Oh, first of all, I realized I did something wrong. Because if it's y, it only goes from 0 to 3. Thank you for catching that. Those of you that saw it, I appreciate it. Those of you that didn't, okay. Ooh, I caught it before you did, which is not always easy. It's just the difference between 10 and 9. So if I actually move this out to 11, this would be 11 squared minus 11 minus y squared squared. All right. So now it's a little tricky, but remember your goal. Figure out if there's a gap or not. It's either wash or disk. If it's a washer method, you've got 2 radii to figure out. And once you figure them out, you're all set. So good luck with this. If you have any questions, I'll be online Tuesday. If you really have pressing needs, you can set up something with me Monday if you'd like to. That's not a problem. And on Tuesday, I'll be posting our very last lesson, which thankfully is just a little more straightforward than this. And that's it. So appreciate you guys' help. Oh, question somebody had before about how much of this is now on that test. If you understand everything that we've done up to this, I think that's almost everything except for maybe 2 questions on that test I gave you. So as long as you skip the ones that say shell method, after this, you'll have everything done. All right. Anyway, I'll see you guys later. Have a great weekend. Bye.